Welcome to Math with Professor V. This is video lecture for section 4.1 for business calculus on techniques for finding derivatives. So up until now, when we were asked to find the derivative of a function, we used the limit definition involving the difference quotient. Now we're going to learn other techniques that are actually a lot faster. And so from here on out, unless the directions specify to use the limit definition, you should be using these techniques. So there's different ways that we represent the derivative of a function, and you should be familiar with all the different kinds of notations that there are because you'll see them throughout the course. So the derivative of y equals f of x may be written in any of the following ways. So we'll see it written as f prime of x, that one we've talked about. You'll also see it written as dy over dx. So you're taking the derivative of y with respect to x. You could also see this d dx outside by itself and then f of x, which is really kind of the same thing as this. Because remember, if you think y is f of x, boom, there it is. It's just written off to the side. Or sometimes you'll see capital D with the subscript x of f of x. And this comes up a lot more later on in multivariable calculus. Okay, so these all mean the same thing. Take the derivative of your function with respect to x. So now let's get into the rules. You're probably excited. You're like, what? There's a shortcut. Why didn't we learn it sooner? We'll talk about that another time. Okay, so rules for derivatives. If your function f of x is equal to some constant k, so k is any real number, then the derivative of that constant is equal to 0. Derivative is 0 of any constant. Remember, we made a connection earlier with the derivative of a function and how it equals the slope of the tangent line to the curve at that point. Well, a constant function, y equals k, always has a graph that's a horizontal line. So its slope is going to be 0 throughout. So that it should make sense, the derivative is 0. Now, if you don't have a constant, we have this lovely little power rule that we use. So if your function is x raised to some power n, and n can be any real number, then the derivative is equal to n times x to the n minus 1. So what just happened here? Well, we take the exponent, that n, and you actually bring it down in the front, you multiply by it, and then you subtract 1, and that's your new exponent. So let me show you a little baby example just to make sure it's making sense. So say your function f of x was x cubed, and you want the derivative. So this technique, this power rule tells us you can take that 3, bring it down in front, multiply by it, and then you're going to have x to the n minus 1, to the 3 minus 1 now, which is 2. So the derivative is 3x squared. Okay, now we have another rule that tells us if you have a constant times a function, so say k is some real number, and as long as g prime exists, then the derivative of f of x, which is that constant times g of x, is just your constant times g prime of x. The rule looks a lot worse than it is. Let me show you an example right now. You're going to feel better about it, okay? So say your function is 4x cubed. So here's the two pieces. Basically, you have this constant, and then you have x cubed, right? So if you want to find the derivative, you just leave the constant alone. He just comes along for the ride. And then you take the derivative of x cubed, which we just did a second ago. It's 3x squared. And that's your derivative. So constant, leave it alone, just hang it out, tack it along, and then you do the derivative of the function, the variable portion, and then you just clean up, so then you're left with 12x squared. And you'll get to a point where you're just going to do that seamlessly in one step. You'll look 4x cubed, bring it down, 3 times 4, that's 12, and then now subtract 1 from the exponent. Okay, and then last rule tells us if your function is involving addition or subtraction of multiple terms, and as long as you can differentiate each of the terms, then when you take the derivative, you just go term by term. Okay, so you don't need to sit there and like make flashcards with these rules, just know how to apply them. That's the most important thing. So let's practice right now. How exciting. Find the derivative of each function. So we have y equals 8x cubed minus 5x squared minus x over 12. If it's helpful, think of this x over 12 as 1/12 times x to the first. That might help you, okay? So here we go. dy dx, or you could write f prime of x, but since they didn't call it f of x to begin with, they called it y. I'm more inclined to use this notation, dy dx. Let's go term by term. So 8x cubed, that 8, you're just gonna leave him alone. He's just hanging out, coming along for the ride. And then I need to multiply that by the derivative of x cubed. So you bring the 3 down front, and then you're gonna have x raised to the second power now. Minus, now 5 is just hanging out. I'm gonna multiply by the derivative of x squared. So you bring the 2 down front, and then you're gonna have x to the first power now. Minus, and then leave the 1/12, that constant's just hanging out. And then you have x to the first power. So you bring that exponent down in the front. So 1 times x to the 0. Okay, how are we doing up to here? Good. Now let's just clean up everything. So this will be 24x squared minus 10x minus, now look at this, x to the 0 is just 1. So then I have negative 1/12 times 1, so just minus 1/12. And that's our final answer. That's our final answer. So I wonder if you noticed something. When you have the derivative of some constant times x to the first, it just ends up being that constant. So when did that come up? Right here. We had the derivative of 1/12 x to the first, and the derivative was just 1/12. We kept the minus sign. But if you want to see, this is just a faster way of doing it. If you want to take the derivative of 5x, it's just 5. The derivative of negative 3x, negative 3. Okay, because you're always going to have x to the first, you bring the 1 down front, that doesn't change the constant. Then the new exponent is 0, and x to the 0 is just going to be 1. So that's why you're just left with the constant after. Okay, let's spice things up. Let's get some decimals going on in here. And the power rule still works for decimals, fractions, even irrational numbers. So notice here when we wrote the power rule out, it said n can be any real number. So very, very useful rule. So f of x is negative 2 times x to the 1.5 plus 12x to the 0.5. So here we go. F prime of x. I'm going to leave that negative 2 alone. And then now, here we go. You bring the exponent down in the front. You're going to multiply by it. And then you're going to have x raised to the 1.5 minus 1. I'm going to write it like that just in case you can't do it all in your head in one shot. Plus, and then leave that 12 alone. Then I bring the exponent down front. That's 0.5 x raised to the 0.5 minus 1. Okay. Now let's keep going. So this is going to be negative 2 times 1.5 x raised to the 0.5. I'm cleaning up just the exponents first, okay? And then I have plus 12 times 0.5 x raised to the negative 0.5 because we have 0.5 minus 1. And then now we can go ahead, last step. We'll just multiply all the constants that are out front and clean up the coefficients. So this will be negative 3x to the 0.5 plus 6x to the negative 0.5. You could leave it like that, but most of the time if we have a negative exponent, we put it in the denominator. So I'm going to do that. So we have negative 3x to the 0.5 plus 6 over x now to the positive 0.5. Okay, so just always check with your instructor how they want the final answer written. If they always want negative exponents in the denominator or not. Just make sure you always do what makes them happy so you get full credit. Okay, let's move on. Another example. Y equals negative 100 times the square root of x minus 11x to the 2/3. Now, before we get started, anytime you see a radical in your function, before you take the derivative, you want to rewrite it using rational exponents. That way you can apply the power rule more easily. So it's very obvious. So I'm going to rewrite this as y equals negative 100 x to the 1/2 minus 11x to the 2/3. You see that? So now it's very clear when I say, oh, I'm going to bring the exponent down front, that it's a 1/2. And then when I subtract 1, we'll figure out the new exponent. It's too much to try to do it all in your head right now when you just learned the power rule if you leave the square root in there. So don't do that. Don't do that for now. So dy dx is going to equal, we have negative 100 times, so we're just going to take the derivative of x to the 1/2. It's going to be 1/2 x. The new exponent's 1/2 minus 1, so that's negative 1/2. Minus 11 times, and then derivative of x to the 2/3. You bring that exponent down in the front. Then you're going to have x to the 2/3 minus 1. That's 2/3 minus 3/3. So that's negative 1/3. Okay. So far, so good? Okay. Now let's clean up. So we've got negative 100 times 1/2. That's negative 50. X to the negative 1/2. Minus, remember this 11 is 11 over 1 if it helps you. So then when you multiply these constants, just multiply the numerators, multiply the denominators. So it's 22 over 3 x to the negative 1/3. And then I would say, yeah, let's rewrite all the negative exponents in the denominator again. So this is going to be negative 50 over x to the 1/2 minus 22. The 3 is already in the denominator, and x to the 1/3 will come to join it. Okay? Very good. There's our final answer. If you want, you can rewrite this x to the 1/2 as square root of x, since it was a square root in the beginning, or you can leave it. So again, check with your instructor. I'll do it just in case that's how they want it. Negative 50 over rad x minus 22 over, but you know, then this should be 3 cube root of x. So I don't know. Check with them what they want. Okay, that's another option. Okay, you guys, let's see if we can do it all in the same step and not have to keep the constant out separately and combine after. Let's just try to go for it and multiply whatever coefficient or constant is there already with the derivative. I think we can handle it. Here we go. Dy dx equals, you're going to bring this exponent down front and multiply by it. So 5 times negative 5, that's negative 25. And then you're going to have x raised to the negative 5 minus 1. It's going to be negative 6, right? But with negative exponents, you got to be careful when you subtract from them. So I just wrote that out step by step for you. Next one, negative 6 times negative 2, that's going to be plus 12 x to the negative 2 minus 1. And then last one, you bring that negative 1 down front, so negative 13 x to the negative 1 minus 1. How are we doing? You're surviving? Okay. So then this is negative 25 x to the negative 6th plus 12 x to the negative 3rd minus 13 x to the negative 2nd. And then, I mean, the problem gave us negative exponents that weren't in the denominator from the beginning, but let's just put them all in the bottom at the end. So this is negative 25 over x to the 6th plus 12 over x cubed, and then minus 13 over x squared. All right, very good. Let's move on, try another one. Why don't you guys pause the video, try this one on your own. So y equals 3 over x to the 6th plus 1 over x to the 5th minus 7 over x squared. I'm going to give you a hint though. Before you start it, you want to rewrite everything using negative exponents so you can use the power rule. So first rewrite this. This is 3x to the negative 6th plus 1x to the negative 5th minus 7x to the negative 2nd. So now pause the video, try this one on your own. Did you pause it? I hope you did. If you watch me do them, you might be like, oh yeah, I get it. I'm following along. But you know, it's an entirely different story when you have to go take your test and do it all by yourself and I'm not there. So when you have to solve a problem and come up with the steps on your own, it takes a whole different level of understanding than just following along. It's like, I love gymnastics, but just because I watch hours of Olympic gymnastics does not mean I'm going to do anything impressive if I get on a balance beam. So same idea. Okay. dy dx is going to be, I'm going to do it all in one step, okay? So negative 6 times 3, that's negative 18, x to the negative 7th. Bring that negative 5 down front, so negative 5x to the negative 6th, and then this is going to become positive 14x to the negative 3rd. And then usually for our final answer, let's put all those negative exponents downstairs in the denominator. So this is negative 18 over x to the 7th minus 5 over x to the 6th, and then plus 14 over x cubed. Beautiful. Did you get it right? Oh, good. Okay, next one, g of x equals x cubed minus 4x over the square root of x. Ooh, we haven't done a fraction before, and we're only using the rules of this section, so basically just the power rule and extensions of it. So we don't want to have a fraction. There's a rule, another rule that we're going to learn later on if you can't rewrite it and get rid of it. But what we're going to do is split that denominator underneath each of the terms of the numerator. So this is x cubed minus 4x over, remember square root of x is x to the 1/2, yes? Oh, good. So then this is x cubed over x to the 1/2 minus 4x over x to the 1/2. And then from here, we're going to simplify because remember when we're dividing two terms with the same base, you can simplify by subtracting their exponents. So you always do top minus bottom. So 3 minus 1/2, this is 6/2 minus 1/2. I'm going to have x to the 5/2 minus, and then this is 4x to the first, remember? So 1 minus 1/2 is 1/2, and the 4 just hangs out, comes along for the ride. So I haven't taken the derivative yet at all. I haven't done any calculus. This is just rewriting g of x. So it's in derivative friendly format. So we can go ahead and use the power rule. So let's hop to it then. G prime of x is going to equal, you bring that 5/2 down front, and then you're going to have x raised to the 5/2 minus 1. So 5/2 minus 2/2 is 3/2 minus, and then keep that 4 times 1/2. I'll do it in 2 steps so nobody gets so confused. X raised to the 1/2 minus 1, which is negative 1/2. Okay, and then let's clean everybody up. So this is 5/2 x to the 3/2 minus 2 over, you can do x to the 1/2 or square root of x. And that is it. Okay, voila. How was that one? I have one more. And after, in a future lesson, we're going to learn a different way to take the derivative for this function. But just for now, we're going to use only the methods that you've learned in this section, okay? So h of x equals x squared minus 1 cubed. So before I can use the power rule, I actually need to just expand and multiply out this whole thing. So h of x equals, if you want to break it down, it's x squared minus 1 squared times another x squared minus 1, right? That's how we have 3 of them. And then x squared minus 1 squared, if I FOIL all that out, You could write it twice, or hopefully you remember the rule. Square the first term, keep the sign the same, and then you do these two terms multiplied by each other and then double it. So x squared times 1 times 2, this is going to be 2x squared, and then the last term you just square, so you have plus 1, and then times x squared minus 1. And then now you just have this big foiling party. So you're going to go, this is x to the 6th minus 2x to the 4th plus x squared, x to the 6th minus 2x to the 4th plus x squared minus x to the 4th plus 2x squared, and then minus 1. And then let's see, I think we can combine some like terms, right? So we've got x to the 6th minus 3x to the 4th plus 3x squared minus 1. So again, I haven't done any calculus yet. I'm just rewriting the function so that I can apply the power rule that we just learned. So now let's hop to it. Derivative time. H prime of x is going to be derivative of x to the 6th. You bring the 6 down front. Subtract 1. We'll have x to the 5th. Minus, next is 12x to the 3rd. Plus 6x to the 1st, and then what's the derivative of a constant? Very good, it's 0. So here's our derivative. And then later in a future lesson, we'll learn a different way to take the derivative. We'll learn more rules besides the power rule, but that's all we have for this section right now. Okay? Good. So now we're gonna look at finding equations of tangent lines to curves. And we've asked this question before, but this time we can find the slope of the tangent line using our quick differentiation rules instead of having to do the limit definition. So here we go. Find the slope and equation of the tangent line to the graph of the given equation at the given value of x. So y equals negative 3x to the 5th minus 8x cubed plus 4x squared. And they want the equation of the tangent line to this curve at x equals 1. So anytime you're asked to find the equation of a line, you need two things. You need a point and you need a slope. They told me to find the equation of the tangent line at x equals 1. So I know the x coordinate of the point is 1. I have to go find the y coordinate. So how am I going to do that? I'm just going to plug it in for x into the function that was given. So to get the point, I need y of 1, which is negative 3 times 1 to the 5th is 1, minus 8 times 1 cubed is 1, and then plus 4 times 1 squared, which is 1. So this is what? Negative 3 minus 8 plus 4, negative 11 plus 4, negative 7. So my point is at 1 comma negative 7. All right, very good. Now I need the slope. So how do I get the slope? Well, now that we are calculus students, we're going to take the derivative. The derivative is a function that will give me the slope of the tangent line to the curve dependent on whatever x value I plug in. So first let's find dy dx. So we have this lovely little function here. Hopefully we're good at taking derivatives so we can work on this guy. Negative 3 times 5, that's negative 15x to the 4th, very good. Minus 8 times 3, that's 24x squared plus 8x. So this is not the slope you're going to use. This gives you the formula or the equation to help you find the slope of the tangent line dependent on x. You have to plug in whatever x is to actually get that number, to get m. So they told me x is equal to 1. So m, the slope of our tangent line, is equal to, and this is another kind of notation, if you want to say plug in something to the derivative, you draw this straight line. That means evaluate it at x equals 1. So I'm plugging in 1 for x into the derivative. Negative 15 times 1 to the 4th minus 24 times 1 squared plus 8 times 1. So that's negative 15 minus 24 plus 8, so that's negative 31. So that's my slope. My slope for my tangent line is negative 31. So then now we can put it all together. Remember point slope form? So we had y minus y1 equals m times x minus x1. So my point 1, negative 7, that's x1, y1, and then the slope is negative 31. So we're going to have here a nice dark blue for this. Y minus negative 7 equals negative 31 times x minus 1. So this is y plus 7 equals negative 31x plus 31. Always put it in y equals mx plus b form unless instructed otherwise. So y equals negative 31x plus 24. Okay, beautiful. How was that? This is a question you're going to be asked often. So remember, slope and equation of the tangent line, take the derivative, plug in the given value of x. Now, we can do some different applications involving tangent lines. Look at the following example. It says, find all values of x where the tangent line is horizontal. And then the function here that's given is x cubed minus 5x squared plus 6x plus 3. So this time they didn't give me a value of x to plug in after I find the derivative. They want me to find x so that the tangent line is horizontal. So let's think. What do I know about horizontal lines? Well, if a line is horizontal, that means its slope is 0. M equals 0. So in this particular case, if the tangent line is going to be horizontal, that means the derivative is equal to 0. So first we're going to find the derivative and then we'll set it equal to 0 and solve for x. So let's go ahead, find the derivative. F prime of x is going to be 3x squared minus 10x plus 6. This is the derivative. I want to know everywhere that this is equal to 0. I want to find all x's such that 3x squared minus 10x plus 6 is equal to 0. So I'm setting the derivative equal to 0. Is it going to factor? No, I'm so sorry. So it's time to bust out the quadratic formula. So x equals opposite of b plus or minus square root b squared will be 100 minus 4 times 3 times 6 all over 2 times 3. So that's 10 plus or minus square root, that's 100 minus 72. So this is rad 28 over 6. 28 is 4 times 7, so I can rewrite this as 10 plus or minus 2 rad 7 over 6. And then we can divide everybody by 2, so this is going to be 5 plus or minus rad 7 over 3. So these are the values of x where the tangent line is horizontal. Technically we have two solutions. X equals 5 plus rad 7 over 3, which is about 2.549. And then also x equals 5 minus rad 7 over 3, which is about 0.785. So just always check if your instructor wants exact answers. If the directions say give an exact answer, it's this one, exact, with the radical and everything not plugged into your calculator. If they tell you to round to a certain number of decimal places or they set up a rule in your class, then do that. The reason this one's called exact is because you can decide afterwards, if you put it in a calculator, how many decimal places you want. There's no rounding that's occurred, right? No information is lost. Here, what if someone's like, oh, but I want it to 5 decimal places and I just gave you these 2 answers. Then you're like, oh, I don't know what the next 2 are. But if I give you the answer this form with the radical, no rounding has occurred. You can decide the degree of accuracy should you choose later on. So that's why that one's exact. Okay, let's do one more before we move on because this idea is so important. Why don't you guys pause the video, try this one. Find the equation of the tangent line to the curve at the given value. We have y equals x to the fourth minus 5x cubed plus 2, and it's at x equals 2. So pause the video, give it a try. Okay, did you do it? So remember, we need two things, a point and a slope. So the point, they told me the value of x. Now I need to figure out what is f of 2. So that would be 2 to the fourth minus 5 times 2 cubed plus 2. That's 16 minus 5 times 8 plus 2. 16 minus 40 plus 2, that's negative 22. So the point is at 2 comma negative 22, okay. And then the next thing I need is the slope. So how do I get the slope of the tangent line? I take a derivative, and then that's 4x cubed minus 15x squared plus 0. Is this what I'm going to actually plug in for the slope? No. The slope needs to be a number. So I'm going to plug in x equals 2 now to actually get m for my tangent line. So m tan equals dy dx. Draw that straight line. I'm plugging it in, or I'm evaluating it at x equals 2. So that's 4 times 2 cubed minus 15 times 2 squared. What's this going to give us? 4 times 8 minus 15 times 4. So 32 minus 60, negative 28. So there's my slope. And then now we're going to just put it all together in point slope form. So we have y minus y1 equals m times x minus x1. So this is going to be y plus 22 equals negative 28x plus 56. So y equals negative 28x plus 34. Et voila. Good. Did you get it right? I hope so. If you made a little boo-boo, just keep note of what sort of errors you make. The more you learn, like what your weaknesses are or what kind of silly mistakes you tend to make, you can be proactive and be on the lookout in the future. So it's always a good learning experience. Okay, last topic. We are business calc students, aren't we? So now we want to look at some applications here. And the biggest one is marginal analysis. So in economics, the word marginal refers to rates of change. Marginal cost refers to the rate of change of the cost. Roughly speaking, the marginal cost at some level of production X is the cost to produce the X plus first item, the one that comes after it. And then we can also talk about marginal revenue, marginal profit in the same way. Anytime you're using marginal analysis, you bust out the derivative. So if you see the word marginal, you think I'm taking a derivative, okay? Marginal derivative, marginal derivative. So assume that a demand equation is given by Q equals 5,000 minus 100p. Part A, find the revenue function R of Q and the marginal revenue function R prime of Q. So remember, revenue is equal to price times quantity, P times Q. And I need my revenue function in terms of Q. So Q should be the only variable in the function besides R, which is on the left-hand side. So notice here, they gave me Q as a function of P. That's no good. I don't want to plug this in for Q because then I'm going to have R as a function of P, and I need R as a function of Q. Oh me, oh my. So what are we going to do? We're going to take this demand equation, and I'm going to solve for P. I'm going to get P by itself. So here we go. So Q equals 5,000 minus 100p. I'm trying to get P by itself. So move the 5,000 over. Q minus 5,000 equals negative 100p. And then we're almost there. Divide everybody by negative 100. Okay. So what are we going to have now? So this is gone. Fabulous. Q divided by negative 100 is negative 0.01 Q, and then negative 5,000 divided by negative 100 becomes positive 50. So this is what P is equal to. So then, okay, finally, now I can say R equals, instead of P, I'm going to write all of this stuff. So that's negative 0.01 Q plus 50 times Q. So what just happened? This P is equal to negative 0.01 Q plus 50, and then I still have this Q over here. So now I can say R is a function of Q, right? There's only Q's on the right-hand side. And then just distribute this Q through. So that's negative 0.01 Q squared plus 50 Q. Whew, we made it. Okay, there's R of Q. Then they asked for the marginal revenue function, R prime of Q. Okay, R prime of Q is going to be, bring that exponent down front, multiply by it. So it's going to become negative 0.02 Q to the first plus derivative of 50Q is just 50. So there's my marginal revenue function, R prime of Q. Good. Here we go. Let's use these functions for something now. Part B, find and interpret the marginal revenue for Q equals 500 units. So marginal revenue means plug it into the derivative. So we want R prime when Q is 500. So that's negative 0.02 times 500 plus 50. So this is going to be negative 10 plus 50, which is 40, and we're in dollars, I'm pretty sure. Did they say? No, it could be euros. Who knows what it is? Let me not put some units so brazenly that they didn't tell me about. Okay. Anyways, we'll just box it. And then now we're going to interpret it for the people. We're going to tell them what this 40 means. So after 500 units have been sold, the revenue increases by 40, whatever monetary system we're in, per unit. Okay, so going from 40 to 41 units in production increases our revenue by 40. Probably dollars. I don't think your class is going to use a different money system, but okay, let's look at the next part. They're asking us, suppose the cost of producing Q units is given by C of Q equals 3,000 minus 20Q plus 0.03 Q squared. Find the marginal profit function. What in the world? Profit? You just give me a cost equation. What are they doing? Okay, remember, profit, that's capital P, not lowercase, because lowercase p is price. So capital P equals revenue minus cost. Yes? And we learned we can differentiate across a sum or difference. So P prime would be R prime minus C prime. I already have R prime. I can get C prime because they gave me C right here. So C prime of Q is derivative of cost function, marginal cost function. Derivative of 3,000 is 0. Derivative of negative 20Q is negative 20 plus derivative of 0.03 Q squared. You bring that 2 down front. Now I have 0.06 Q to the first. Oh, look at us. Okay, so then P prime of Q equals R prime of Q, I have it right up here, remember? Negative 0.02 Q plus 50 minus, and then C prime, we just computed what C prime was. Put parentheses though, because you have to subtract the whole thing. So negative 20 plus 0.06 Q. Good? I love it. And then capital P prime of Q, that's our marginal profit function, is going to be, combine your like terms. So this is 50 plus 20, that's 70. And then negative 0.02 Q minus 0.06 Q is negative 0.08 Q. Beautiful. Okay. Find and interpret the marginal profit when Q equals 500 units. So marginal profit, I'm plugging it into P prime. Q is 500. That's 70 minus 0.08 times 500. And this comes out to 30. Probably dollars, but I dare not say. So what this means is after 500 units have been sold, the profit increases by 30 per unit. Okay? And then E, at what level of production will the profit be $0? Oh, so we are in dollars. Okay, then. Let me go back. But don't assume, you guys. Are any of you international business majors? See, who knows? Okay, good. At what level of production will the profit be $0 for producing an extra unit? So what they want to know is, when will the marginal profit be $0? So I'm going to set P prime of Q equal to 0 and solve. So P prime of Q, where are you? Up here. Okay, so then we have 70 minus 0.08 Q equals 0. That means 70 equals 0.08 Q. So Q equals 875 units. This is very useful information. That means going from producing 875 to 876 units will not increase your profit. Oh, so when you're doing marginal analysis, it can be very helpful in determining for a business what level of production maximizes their revenue, maximizes their profit, etc., etc. So that concludes the lesson. I hope you enjoyed it. Give the video a thumbs up, subscribe if you haven't already, and stay tuned. I have more lectures on business calculus coming your way. Also, if you need to review any pre-calc or algebra topics or whatnot, then you can check out the rest of the videos I have on my YouTube channel. Everything's organized into playlists. And please follow me on Instagram and TikTok, Math with Professor V. I love you all so much. I'll be back sooner than later. Bye.